Hey, and welcome back. In this episode, I'm going to be doing exercise number 3 in homework 4. So, number 1, implement a function XOR that takes a list of bools and returns a single bool, which returns true if and only if there are an odd number of true values contained in the input list. Your solution must be implemented using a fold. So this function is called XOR because all it's doing is XORing each pair of booleans. Well, it's basically doing a fold with an XOR operation. So I'll give you, or I'll show you an analogous function from the prelude. And takes a list of bools and returns a bool and returns true if all of the booleans in the list are true and false otherwise. And this is nothing more than a fold using the AND operator with an accumulator starting at true, of course. Similarly, OR is just a fold of the OR binary operator with false as an accumulator. So, XOR is simply folding an XOR function starting with false, and I couldn't find an XOR function in the prelude or anywhere else for that matter, so we can simply roll our own. And then, of course, fold that operator. And that's how you do it. So really quickly, I can show you how to make an infix function. If I wanted to call XOR op something like, I guess because caret is taken, I'll settle on dot caret dot. Oops. And I can give it a fixity of 4, which is the same as AND. What? Right. Can I get rid of the fixity? Did I have that backwards? Oh, okay. I had the order of the operations backwards. Anyways, that's how you do that function. So, next one, implement map as a fold. So, if you haven't done this before, I think that you should stop watching this video or pause it or whatever and try it on your own, because I think it's good for beginners to do this one in particular, but I'll do it now. So the fold function takes some A and B is our accumulator and does some stuff, and it has a default value of, say, empty list, and the second argument to map is being curried here. So what does this function have to do? Well, we're trying to apply f to all arguments, And so we can start by doing f on a, and then we want to cons that back onto the list. Well, the list is simply b, which is our accumulator. And that is how you define map as a fold. And you can get a little fancier with this. I can use a section here to get rid of the b argument that compiles. I can actually change this to prefix notation. Make sure it compiles, and then this is just the composition of cons on f, and I can get rid of the arguments a in that way. And that's about as far as you can go with it, but I think this is the most clear. Alright, thanks for watching.